A tiny patch of sky no bigger than a grain of sand held at arm's length containing thousands of galaxies, each one a swirling city of billions of stars stretching back to the dawn of time. That's not science fiction, it's the reality unveiled by the James Webb Space Telescope. This remarkable machine, floating a million miles from Earth, has redefined our understanding of the cosmos, pulling back the veil on a universe more vast, complex, and ancient than we ever imagined. Today, we're diving deep into the James Webb Space Telescope's revelations about the early universe, exploring how its discoveries are reshaping our grasp of cosmic history, galaxy formation, and humanity's place in the grand tapestry of existence. Buckle up, because this journey will take us to the edge of time itself. And if you're as excited about space as I am, hit that like button and subscribe for more cosmic adventures. Let's start with what makes the James Webb Space Telescope, or JWST, so extraordinary. Launched on December 25, 2021 by NASA in collaboration with the European Space Agency and the Canadian Space Agency, this $10 billion marvel is the most advanced observatory ever built. Unlike its predecessor, the Hubble Space Telescope, which primarily observed invisible and ultraviolet light, Webb is designed to capture infrared radiation. Why does that matter? Infrared light allows us to peer through cosmic dust clouds and see light that has traveled for billions of years, stretched by the expansion of the universe into longer, redder wavelengths. This makes Webb a literal time machine, capturing photons that left their sources when the universe was just a fraction of its current age, 13.8 billion years. Its 6.5-meter golden mirror, made of 18 hexagonal segments, and its sun shield, the size of a tennis court, work together to detect the faintest whispers of light from the cosmos, cooled to just above absolute zero to avoid interference. This engineering masterpiece isn't just looking at stars, it's looking at the universe's baby pictures. Now let's talk about what Webb has actually shown us. One of its first jaw-dropping images, released in July 2022, was the deep field of SMACS 0723, a galaxy cluster 4.6 billion light-years away. This image wasn't just beautiful, it was revolutionary. In a patch of sky smaller than a pinhead, Webb revealed thousands of galaxies, some so distant their light took over 13 billion years to reach us. That's light from when the universe was less than a billion years old, a time when galaxies were just beginning to form. What stunned astronomers wasn't just the number of galaxies, but their complexity. These weren't simple, formless blobs of gas, as earlier theories predicted. They were fully formed galaxies with intricate structures, suggesting that galaxy formation happened much faster than anyone expected. This discovery, backed by data published in journals like the Astrophysical Journal, forced scientists to rethink models of cosmic evolution. The universe, it turns out, was a busy place almost from the start. But how does Webb see so far back in time? It's all about redshift. As the universe expands, light from distant objects stretches, shifting toward the infrared end of the spectrum. Hubble could see some of this, but its capabilities tapered off in the near-infrared. Webb, with its near-infrared camera, NIRCam, and mid-infrared instrument, MIRI, picks up where Hubble left off, capturing light that's been traveling since the universe's infancy. For example, in 2023, Webb identified galaxies like JADE's GS-Z13-0, which dates back to just 320 million years after the Big Bang, making it one of the oldest galaxies ever observed. This is like finding a thriving metropolis in a time when we expected only scattered villages. These findings, confirmed by teams at the University of Arizona and published in Nature Astronomy, suggest that massive stars and even supermassive black holes formed much earlier than previously thought, challenging our understanding of how quickly matter clumped together after the Big Bang. Let's zoom in on one of the most mind-bending aspects of Webb's discoveries: gravitational lensing. Galaxy clusters like SMACS 0723 are so massive that their gravity bends space-time, acting like a cosmic magnifying glass. This lensing effect amplifies the light from galaxies far behind the cluster, allowing Webb to see objects that would otherwise be too faint or distant. In the SMACS 0723 image, you can see arcs and distorted shapes. Those are galaxies billions of light-years further away, their light warped by the cluster's gravity. This phenomenon, predicted by Einstein's theory of general relativity, lets Webb peer even deeper into the universe, revealing galaxies that formed just 200–300 million years after the Big Bang. And each lensed image is a window into the cosmic dark ages, a period when the first stars began to ignite, transforming the universe from a dark, neutral fog into the star-filled cosmos we know today. It's like reading the opening chapter of a book that's been hidden for 13 billion years. Webb's infrared vision also unveils star-forming regions that were once shrouded in mystery. Take the Carina Nebula, about 7,600 light-years away, which Webb imaged in 2022. Its cosmic cliffs image revealed towering pillars of gas and dust, sculpted by the intense radiation of young, massive stars. These regions, hidden from Hubble's visible light view by thick dust clouds, are now visible in stunning detail. Webb's data shows how stars are born in chaotic, turbulent environments, with jets of material blasting out from forming stars, shaping their surroundings. This isn't just pretty pictures, it's a glimpse into the processes that create the building blocks of planets and, potentially, life. By studying these nurseries, astronomers at institutions like Caltech are piecing together how our own sun and solar system formed 4.6 billion years ago, connecting the distant universe to our own origins. Now, let's address a common misconception: the idea that Webb's images prove the Big Bang never happened. Some online discussions, especially on platforms like X, have claimed that the presence of complex galaxies so early in the universe contradicts the Big Bang theory. This is a misunderstanding. The Big Bang model, supported by decades of evidence like the cosmic microwave background and the universe's expansion, remains robust. What Webb's data suggests isn't that the Big Bang is wrong, but that our assumptions about early galaxy formation were incomplete. The universe was more active, more structured, and more complex in its infancy than we thought. Instead of debunking the Big Bang, Webb is refining our understanding of what happened in the first billion years, pushing cosmologists to develop new models that account for rapid star and galaxy formation. Science thrives on surprises like these. It's how we grow. Beyond galaxies and star nurseries, Webb is revolutionizing our understanding of exoplanets. In 2022, it captured the first direct image of an exoplanet, HIP 65426b, a gas giant 350 light-years away. More impressively, Webb's spectroscopy has detected molecules like water, methane, and carbon dioxide in the atmospheres of planets like WASP 96b. These observations, detailed in papers from the Max Planck Institute for Astronomy, are a game-changer. They bring us closer to answering one of humanity's biggest questions. Are we alone? By analyzing the chemical makeup of distant worlds, Webb is laying the groundwork for detecting biosignatures, signs of life like oxygen or organic compounds. Imagine the moment when we find a planet with an atmosphere that screams life. That possibility, once pure science fiction, is now within reach thanks to Webb's precision. The human story behind Webb adds another layer of awe. This telescope wasn't just a triumph of technology, it was a testament to perseverance. Conceived in the 1990s, the project faced decades of delays, budget overruns, and skepticism. Engineers at Northrop Grumman and NASA had to solve unprecedented challenges, like folding a 6.5-meter mirror to fit inside a rocket and deploying it flawlessly in space. The sun shield, made of 5 ultra-thin layers, had to unfold perfectly at the Lagrange point 2, a million miles from Earth, where gravitational forces balanced to keep Webb stable. Every step was a gamble, yet on January 8, 2022, when the final mirror segment locked into place, the world celebrated a monumental achievement. This wasn't just a win for scientists. It was a victory for human curiosity, proving we can build tools to touch the edges of the universe. Webb's discoveries also spark philosophical questions. When we see galaxies that formed 13.5 billion years ago, we're not just looking at light, we're confronting our place in the cosmos. The sheer scale of the universe, with its hundreds of billions of galaxies, each containing billions of stars and countless planets, makes Earth seem impossibly small. Yet the fact that we, a species on a tiny rock orbiting an ordinary star, can build a machine to see this far fills me with wonder. It's a paradox. The universe's vastness humbles us, but our ability to explore it elevates us. As Carl Sagan once said, we're a way for the cosmos to know itself. Webb embodies that idea, turning distant light into knowledge and mystery into discovery. The telescope's impact extends beyond science into culture. Its images, like the glowing pillars of the Carina Nebula or the warped arcs of lensed galaxies, have become icons of our era. They're shared across social media, inspiring artists, writers, and dreamers. In classrooms, they're sparking curiosity in students who might one day become astronomers. On X, posts about Webb's discoveries generate millions of views, with users marveling at the beauty and scale of the cosmos. These images aren't just data, they're a shared human experience, uniting us in awe. If you're feeling that awe right now, drop a comment below and tell us what Webb's images mean to you. Your thoughts are part of this cosmic journey. Webb also challenges us to think about the future. Its observations of early galaxies tell us the universe was a dynamic, creative place from the start, forming stars and black holes at a breakneck pace. This raises questions about what's next. If galaxies formed so quickly, what does that mean for the evolution of the cosmos? Will we find habitable worlds in our galactic neighborhood? And as we push toward exploring Mars or building lunar bases, how will Webb's insights guide us? Its exoplanet data could shape the search for life, informing missions like NASA's planned Habitable Worlds Observatory. The telescope isn't just showing us the past, it's lighting the way forward. Let's not forget the collaborative spirit behind Webb. This wasn't a solo effort. Thousands of scientists, engineers, and technicians from 14 countries worked together, overcoming language barriers, time zones, and technical hurdles. The European Space Agency provided the launch vehicle, and Canada contributed key instruments. This global effort mirrors the universe itself, where galaxies don't exist in isolation but are connected in vast cosmic webs of dark matter and gravity. Just as the universe is a network of interactions, Webb's success is a network of human ingenuity, reminding us that our greatest achievements come when we work together. One final thought: Webb's images remind us that the universe is alive. Stars are born, galaxies collide, and black holes feed, all in a cosmic dance that's been going on for billions of years. When we look at a Webb image, we're not just seeing static dots of light. We're witnessing a story that began before Earth existed and will continue long after we're gone. Yet, in this moment, we're part of that story. Webb lets us read chapters written in light, connecting us to the universe's past, present, and future. It's a reminder that exploration isn't just about finding answers, it's about embracing the questions that keep us looking up. As we wrap up, let's reflect on what the James Webb Space Telescope means for us. It's more than a machine. It's a bridge to the unknown, a tool that turns faint glimmers of light into profound truths. It shows us a universe that's not just vast, but vibrant, not just ancient, but ever-evolving. It challenges us to rethink our assumptions, to dream bigger, and to keep exploring. So, the next time you look at the night sky, remember, every point of light is a story, and Webb is helping us read them all. If this journey through the cosmos has sparked your curiosity, hit that like button, subscribe, and share your thoughts in the comments below. What's your favorite Webb discovery? Let's keep the conversation going. Thanks for watching, and until next time, keep looking up at the stars.